In the first video of this differentiation chapter, we looked at what dy by dx. It was also referred to as the gradient function because it allowed us to find the gradient at any specific point on a curve. This is very useful for us because we can now find the line equation of a tangent because the gradient at, say, this point here is actually going to be equal to the gradient of the tangent. So if I differentiate the function, plug in the x value, that will give me the gradient of the tangent. In the textbook, they do give you this equation here, but this is another example of an equation which you guys should not remember. We could just solve the questions rather than using this equation here. So let's look at an example. Let's say I have the equation y is 4 root x, and I want to find the line equation of the tangent at, let's say, the point 9, 12. So first things first, I need to find the gradient. So let's differentiate it first. So dy by dx will just be equal to 2x to the power of minus half, which is just 2 over root x. And now plug in my x value, which was 9, right? So it'll be 2 over root 9, 2 over 3. So that's going to be the gradient at that specific point and also the gradient of the tangent at that point. So we can say it's going to be y is 2x plus c. The c I can just easily find plugging in 9, 12, and it comes out as 6. So the line equation of the tangent is y is 2x plus 6. We can also find the equation of the normal because remember, the normal line is actually 90 degrees to the tangent line. So if I know the gradient of the tangent, then I can just find the negative reciprocal of that gradient and use that as the gradient of the normal. Let's look at an example. So let's say I have the function f of x is 12 minus 4x plus 2x squared. And I want to find the equation of the lines for the normal and the tangent at x is negative 1. First things first, I differentiate. F prime of x will give me minus 4 plus 4x. I substitute x is negative 1 into it, which will give me the gradient as negative 8. Note, this gradient is the gradient of the tangent. So for the gradient of the normal, I just find the negative reciprocal. So it's going to be minus 1 over negative 8, which is just 1 over 8. So the line equation for tangent will be y is equal to minus 8x plus c, and the normal will be y is 1 over 8x plus c. We just have to find the c value. We're looking at the point when x is negative 1, right? So we need to find the y value. This we can do that by plugging it into the original function, not the derivative, but the original one. So f of minus 1 will give me the value of 18. And using negative 1, 18 as the coordinate, the c values for the tangent, we get as y is minus 8x plus c, and the normal we get as y is 1 over 8x plus 145 over 8. So you can see that finding the derivative or the gradient function will give me the gradient of the tangent, and using that, if we are asked, we can also find the gradient of the normal.